This is Marlena Snellick with A Plus College Ready, and we are going to do part 2 of our solutions unit, and we are going to talk about molarity. So molarity is a way to measure the concentration of a solution. So when we talk about concentrations, we are going to be talking about the molarity. So the first thing that we're going to look at is the formula. So the formula for molarity is very simple. It's just moles of solute divided by volume of solvent. And so in this case, you just want to make sure that your units are correct. So make sure that you have moles on top and that you put liters on bottom to make sure that you get the correct molarity. So make sure you're always in moles and liters. So here is an example problem of how this would work. So calculate the molarity of a solution made with 30 grams of HCl with 500 milliliters of solution. So the first thing that I want to do is I've got to get grams to moles because it's moles over liters. So you would find the molar mass of HCl, which is 36.46 grams, and you would just set up a basic stoichiometry problem. So 30 divided by 36.46 gives me 0.823 moles of HCl. So there's my moles. And then I want to make sure that I have liters on the bottom. So in this case, the problem gave me 500 milliliters. So I'm going to convert milliliters to liters, which would be 0.5 liters. And so once you have it in the correct unit, so moles on top, liters on bottom, then you can just put it in your calculator and divide. So 0.823 divided by 0.5 would be 1.65 molar. So the concentration of this solution would be 1.65 molar. So a lot of times what we will do is we will prepare 1 molar solutions and we'll make that like a stock solution that we can use to make other different solutions of varying concentrations. So how do you make a molar solution? The first thing you want to do is measure out 1 mole of the substance. So calculate what 1 mole of the substance is and then measure it out on a balance. So measure out your grams. Then what you want to do is you want to put that into a flask. So you would use a funnel to pour the solid into the flask, and then you would add just enough solvent to make sure you can dissolve the solute. You don't want to fill it all the way up to the desired volume, because if you do, your volume might be off if your solute hasn't dissolved yet. So you want to make sure that you add just enough to dissolve the solute. Mix it around, swirl it. If it doesn't dissolve, add a little bit more, mix it around, swirl it. Do that until all of your solute has dissolved, and then you can fill up your flask to the desired volume, and you should have the correct molarity of whatever solution that you're trying to make. We can use these molar solutions or any kind of stock solution to make a more dilute solution. So a lot of times the solutions that we use in lab are diluted to make them to the desired concentration that we need. So instead of just ordering a bunch of different concentrations, you can order what we call a stock solution, so a solution that has a higher concentration, and then you can add water and dilute it to what you want it to be. So the formula that we use for this is M1V1 equals M2V2, where M1 and V1 is the molarity and the volume before the dilution, so that would be the molarity and the volume of your stock solution, and then M2V2 would be the molarity and the volume after the dilution. So a lot of times when you're trying to make a dilution, so you'll pick the molarity that you want it to be and you'll pick the volume that you want. So you'll have your M2 and your V2. You know the molarity of your stock solution, that's your M1. So what you'll be solving for in a dilution problem is you'll be solving for V1. How much of the stock solution do I need in order to make a diluted solution? So once you figure out how much you need, you would just transfer that amount from the stock solution into an empty flask, put it in there, and then fill it up to the volume of whatever you said that you wanted. So whatever your V2 was, fill that up with water, and then you have your diluted solution with the correct molarity. Now this problem works because molarity times volume gives you the amount of moles, and remember, matter cannot be created or destroyed, so you're calculating the number of moles that you have before and you're creating the same number of moles afterwards. You're just making it diluted. So an example problem of this would be how much concentrated 18 molar H2SO4, so sulfuric acid, is needed to make 1.75 liters of a 6 molar sulfuric acid solution. So There we go. So notice that they gave you your M1, okay, so that would be 18 molar. I don't know my V1, so I don't know how much of the stock solution that I need, so I just leave the V1. Is equal to, I want the solution to be 6 molar in concentration, and I want 1.75 liters of it. So all you've done here is just fill in your information and leave your V1 blank. And then you just solve for your missing variable. So V1 is equal to 6 times 1.75, and then divide that by 18 and you get 0.583 liters. So that means I need 0.583 liters of my stock solution in order to make this diluted solution. And that would be our unit on molarity. So hopefully this was helpful for you, and I will see you for part 3.